Hey YouTube, Soulkill here, and we are on a moving object. In fact, we're moving in many different directions, even though we can't feel them because it's relative to us. We are moving, even though that's just technically not true. Anyway, so of course we're on a planet that's spinning because we have a day and night cycle that doesn't last as long as it takes for the Earth to go around the sun, a year. Instead, it happens every day, even though a day is a constantly changing amount of time. The average is 24 hours, yes, but quite often it's shorter for half of the year, and for half of the year it's longer than that, of course. And this is just because the Earth, although it's spinning at the same speed, that's the important thing to keep in mind. The sun is what it's moving around, and when it moves around the sun, sometimes it has to move further for the sun to return to the original position in the sky, and sometimes it takes less time for it to return because the Earth is going around it, because the Earth's orbit isn't a complete circle, it's eccentric, which means it's elliptical, so it's slightly further at some points from the sun than how far it is at other points. And so a day isn't always 24 hours, it's just the average. We're just lucky to be at a time where the average is a nice whole number. But the thing is, you can actually slow down the Earth's rotation. It's quite easy. It all has to do with angular momentum. Angular momentum is something that is observed all the time. In layman's terms, it just means spinning. Things that are spinning have angular momentum. And angular momentum, you can quite easily change it, as I was saying. And this all has to do with the equation for how you actually form angular momentum. The angular momentum is basically the mass and the inertia, so the angular inertia, which is almost just the mass and also how far the mass is from the center of rotation, the point on which it's rotating, the central axis, times the speed at which it's rotating, the velocity. And you may notice this if you've ever seen ice skaters or other things in general. If they move their mass closer to the center of their rotation in their body, they'll spin quicker. Why is this? Well, because angular momentum always has to be conserved. I'll go for an example. Let's say that angular momentum is 100 arbitrary units. That means that they're spinning at 10 arbitrary units, and the mass and the inertia is 10 arbitrary units. Now, if you move the thing twice as far away from the object, then that means that the inertia is going to be 20 instead of 10 because you moved it twice as far away. But the total still has to be 100, so the speed has to halve from 10 to 5. And it works the other way around, of course, if you were to move it closer to the center of rotation. And this happened with the Earth, because when the Chinese built the Three Gorges Dam many years ago, this shifted 42 billions of tons of water further away from the Earth than it was before. So ever since then, a day has been 0.06 microseconds longer.